For this system of equations, this is number 40 on the skills refresher packet. This one is not initially set up like the other ones with a y equals or an x equals, but there's another method called the elimination or the addition method, where you pick a variable, either x or y, manipulate the equation so that it has an opposite coefficient, like 2 versus -2, 5 versus -5, 1 versus -1, so that when you add the equations together, the variable is eliminated. For this problem, I'm going to go with eliminating the y's first. I have a -1 and a -3. So what I would like to do is to take that -1 on the y and make it a +3 so that they're opposite, +3, -3. So I'm going to do a -3 times that entire top equation. Let me go back. Equals 17. I mean, the entire, you have to do that -3 distribution to every single term. So what that turns into is a -9x plus a 3y equals, let's see, 51, -51. So then when I copy the second equation with it, I get -2x minus 3y equals -4. And what that creates is a system of linear equations where, should I choose to simply add them together or add down, my y terms are eliminated, hence the elimination method or the addition method, and I get -11x equals -55. Divide both sides by -11, and x equals 5. That worked out quite nicely. And then you can take that value of x and substitute it back into either equation, really. I'm going to put it back into the top one. And then you can have it 3 times 5 minus y equals 17. So 15 minus y equals 17. If I subtract 15, I get -y equals 2. And then solving for y, getting rid of that negative would make it y equals -2. So our solution for the system of equations would be x equals 5 and y equals -2. And this, again, was done using something called the elimination method or the addition method. Again, it just depends on which textbook you were taught out of when you first learned this method. That's the answer. X equals 5, y equals -2.